Hello everyone. Databricks has become popular in the last few years for big data and machine learning projects. It's now available on all three major cloud platforms such as Microsoft Azure, AWS, and Google Cloud. In this episode, I'll give you an introduction to Azure's offering of Databricks. I'll then do a demo in which we'll create a Databricks workspace in Azure, and then I'll walk you through the user interface and the various components available within Databricks. And we'll also try and process some data related to COVID-19 using Databricks. We'll aim to do all of this within the next 20 minutes. Hope you're excited. So let's get started. First, let's start by understanding what is Azure Databricks from a higher level. At the core of Azure Databricks is the open source distributed compute processing engine called Apache Spark, which is widely used in the industry for developing big data projects. Databricks is a company created by the founders of Apache Spark to make it easier to work with Spark by providing the necessary management layers. Microsoft makes Databricks service available on its Azure cloud platform as a first-party service. These three offerings together makes Azure Databricks. So let's start with a brief introduction to Apache Spark, and then we'll look at the additional services offered by Databricks and Azure. At a higher level, Apache Spark is a lightning-fast unified analytics engine for big data processing and machine learning. It was originally developed at UC Berkeley in 2009 and open-sourced in 2010 under BSD license. In 2013, it was donated to Apache Software Foundation and seen a significant adoption since. It's been used by internet giants such as Yahoo, eBay, and Netflix for large-scale data processing on multiple petabytes of data on clusters of thousands of nodes. Spark was built with the ground up to address the shortcomings of Hadoop. Hadoop was slow and inefficient for interactive and iterative computing jobs, and it was hard to learn and develop. On the other hand, Spark offers a much simpler, faster, and easier APIs to develop on. Spark can be 100x faster than Hadoop for large-scale data processing by exploiting in-memory computing and other optimizations. Similar to most of the big data engines, Spark runs on a distributed computing platform. Spark has an unified engine to support varying workloads. For example, it doesn't have a separate engine for streaming and batch workloads. It comes packaged with higher-level libraries, including support for SQL queries, streaming data, machine learning, and graph processing. These standard libraries increase developer productivity enormously and can be seamlessly combined to create complex workflows. Let's now take a look at the high-level architecture of Spark, so it'll be easier when we come to discuss the capabilities added by Databricks and Azure. At the center of Spark architecture is Spark Core. This contains the basic functionality of Spark. The Spark Core takes care of scheduling tasks, memory management, fault recovery, communication with storage systems, etc. It also is the home to Spark's main programming abstraction API called RDD, or Resilient Distributed Datasets. RDDs are a collection of items distributed across various compute nodes in the cluster that can be processed in parallel. Spark Core provides the API to create and manipulate these RDD collections. Early development in Spark was done using these APIs, but it's had its drawbacks. It was difficult to use for complex operations, and it was difficult to optimize for Spark. The optimization was mainly down to the developer to write the optimized code. In order to optimize the workload, Spark introduced the SQL engine. It includes the Catalyst optimizer, which takes care of converting the computational query to a highly efficient execution plan, and the Tungsten project, which is responsible for memory management and CPU efficiency. The higher level abstraction, such as Spark SQL and the dataset and the data frame APIs, makes it easier to develop applications and also benefit from the optimizations from the SQL engine. So the recommended approach to develop applications in Spark is to use these higher level APIs rather than the RDD API. The dataset and the data frame APIs can be invoked from any of the domain-specific languages such as Scala, Python, Java, or R. On top of this, we have the set of libraries such as Spark structured streaming for streaming, MLlib for machine learning, and also GraphX for graph processing. Also, Spark comes with its standalone resource manager, but you can choose other resource managers such as Yarn, Apache Mesos, and Kubernetes. Combining all of these components, Spark provides the unified platform for doing streaming, batch, machine learning, and graph processing workloads using a single execution engine and a standard set of APIs. Now we know Spark is a fast execution engine with an easy-to-use set of higher-level APIs. But in order to work with Spark, we will have to set up our own clusters, manage security, and also use third-party products to write our programs. That's where Databricks comes in. Databricks is a company founded by the creators of Apache Spark to make it easier to work with Spark on the cloud. In order for Spark to do its distributed computing, we need to spin up clusters and install software. Databricks gives you the ability to spin up clusters with a few clicks. You can also choose a runtime which is suitable for your needs. For example, you can choose a runtime with ML libraries, support for GPU, etc. Also, you can choose from a wide range of clusters ranging from general purpose, memory optimized, compute optimized, or GPU enabled. It provides a Jupyter Notebook style IDE with additional capabilities to create your applications, collaborate with your colleagues, and also integrate with configuration management tools such as Git. It provides administration controls that you can use to restrict or provide access to your users to the workspace, clusters, etc. On top of this, Databricks provides the Spark runtime, which is highly optimized for the Databricks platform and known to be up to 5 times faster than the vanilla Apache Spark. With the use of Hive Metastore, Databricks also provides the ability to create databases and tables. In order to provide ACID transaction capability, Databricks also comes with the data lake. And a recent addition to Databricks is the SQL Analytics, which provides the data analysts a SQL-based analytics environment. This allows the analysts to explore data, create dashboards, schedule a regular refresh of the dashboards, etc. Also, it comes with managed ML flow on Databricks, which allows us to manage the machine learning lifecycle, including experimentation, deployment, model registry, etc. With the recent announcement from Google in Feb 2021, Databricks is now available on all 3 major cloud platforms such as Microsoft Azure, AWS, and Google Cloud. But Azure's integration is deeper than others. Databricks is a first-party service on Azure. What that means is that on Azure, you will be buying Databricks directly from Microsoft, and all support requests are handled by Microsoft. As a result, it provides a unified Azure portal for Databricks and a single unified bill for all your Azure services, including Databricks. Azure Databricks leverages Azure's security and seamlessly integrates with Azure Active Directory and single sign-on. It provides seamless integration and high-speed connections between various Azure data services such as Azure Data Lake, Blob Storage, Cosmos DB, SQL DB, and Synapse, and also messaging services such as Event Hub and IoT Hub, as well as Power BI and Azure ML. You can seamlessly run Databricks notebooks from Azure Data Factory and integrate with the rest of the data workflow in your data project. And finally, Azure Databricks also connects with Azure DevOps to help enable continuous integration and continuous deployment. So just to summarize, Azure Databricks is a Spark-based unified data analytics platform as a service offering that is optimized for the Microsoft Azure cloud. So now that we understand what an Azure Databricks service is, let's do a demo. In this demo, we'll create an Azure Databricks service, we'll create a cluster, and also we'll create a notebook to analyze some data. So let's get started. Okay, here we are in the Azure portal. Let's click on create a new resource to create the Databricks resource. So I'm searching for Azure Databricks in the marketplace and click create. And I'm going to go with my pay-as-you-go subscription and create a new resource group called Databricks Demo. And I'm going to call my workspace as Databricks Demo as well. And I'm going to leave it in the UK South region, and I'm going to keep the pricing tier as standard. You can go for premium, but we don't need it now. And for networking, you can avoid having any public IPs, and also you can put the Databricks service in your own virtual network, but I'm going to leave them as no, and click next to tags and then review plus create. And validations passed, let's click create. So that's going to deploy the Databricks service. It'll take a couple of minutes. Okay, so the deployment's now complete. Let's go to the Databricks service. And similar to the other Azure services, you've got the IAM for access control and things like that. But we want to launch the workspace. So let's do that. And that's logging in through the single sign-on now. There are three important sections here. In the middle, you've got some shortcuts. So you can create a new notebook from here, create a table, new cluster, and you can access the links for documentation, and you can import data from here. And on the left, you've got the navigation bar. So this is what you'll be mainly working with. So if you wanted to get to data, clusters, all of those you can access from here. We'll get to these in a minute. And on the right hand side, you've got access to your admin consoles and user settings and things like that. So these are the three main areas to navigate from this main screen. But let's go through each one of these here. So from this one, you can, this is your workspace. So you can come in and you can create your notebooks and folders and things like that. So you can create notebooks, libraries, folders, MLflow experiments, and you can import any code from elsewhere. You can export your code in here. So that's the Databricks format. And also you can come into recents. So that'll tell you if you had any recently accessed notebooks or experiments or things like that. So that's specific for your own workspace. And data. So Databricks, as we said before, gives you the option to create databases and tables. So they'll be listed in here. We don't have any at the moment, but we will create one in a bit. And clusters, you can come in here to create your cluster. So you've got different types of clusters. So you can have an all-purpose cluster. And if you have jobs creating clusters, then you will end up having the job clusters as well. And you can have cluster pools as well. And jobs. So if you wanted to schedule your notebooks to run at a certain time every day, then you would come in here and you can create a job. You can define what kind of cluster you want for the job, for the notebook to run on. Then it will create the cluster and run your notebook, and the outputs will be published as well. And models. So if you had any models registered to MLflow, then you would see them here in terms of who created it, when is the last time it's modified, and all of those information will be here. And search, so that is a global search. So that will give you the ability to search the entire workspace for any keywords you want to search on. First, let's create a cluster, because you need a cluster in order to do any processing on Databricks. So let's come over to clusters, and I'm going to create a cluster. I'm going to call mine as demo cluster. And I'm going to go for a single node cluster because we only have very little processing to do here. And we can stick to the Databricks runtime 8. And I'm going to terminate my cluster after 10 minutes of inactivity. So what that means is that if the cluster is not in use for 10 minutes, then it'll auto terminate and you can save cost. And let's go with the node type being offered to us, which is standard DS3v2, which is going to cost 0.75 Databricks units. And you just have to click create cluster to create the cluster. It will take a few minutes to spin up, roughly about 5 minutes. Let's wait for that. Okay, the cluster is now started. The green button here indicates that the cluster is up and running. So the next thing we want to do is we want to upload some data so we can do some transformations on the data. So I've got some data already prepared. So I'm going to just import that. So import and export data, and I'm going to put it straight into the DBFS file system. So the file's in my local drive. So that's called COVID_cases.csv. Let's click open. So the data has now been uploaded. So let's come over to workspace, and now let's create a new notebook. So I'm going to create notebook, and I'm going to call this one as demo Databricks. And I'm going to go for the Python notebook, but you can either choose the language of choice you want to pick from here, or once you're in, you will be able to use magic commands to be able to use any of the languages you choose. So I'll show you that in a minute. So let's pick Python for now, and the cluster is the demo cluster we want the notebook to be attached to, and then click create. So now we're in, but for some reason it hasn't attached the cluster, so let's do that. So that's the demo cluster, and then click confirm. So that's there now. From here, you can write your PySpark commands. So let's explore the data ourselves. Let's now read the CSV file that we imported. So that will be spark.read.csv. And we need to specify the location of our Databricks file system. So that would be dbfs file store tables COVID cases.csv. And I did a shift enter to execute it. Either you do shift enter, or you can just run all, will run every command within your notebook, or you would just come in here and then you can run this cell, or you've got the option to run everything above or everything below. So in this case, just a shift enter would be quite handy just to execute a cell. That's what I did. And now that we got the data frame with the data, so let's have a look at what's in the data frame. So I'm going to use a display command to display the data frame. As you can see here, it hasn't really picked up the header. We got a header in the file. So let's specify the header in the option. Okay, so let's do the display again. And as you can see, it's picked up the header. So let's have a look at the schema. So the schema looks okay for the two fields here, which are strings, but we know that our weekly count is integer. So let's specify that as the info schema so that it can identify the schema correctly. Let's do another option for that. So that would be info schema is true. Okay, let's execute it. As we can see here now, it's identified that as an integer. So that's great. Let's now do a quick aggregation on the data. As you can see, actually, we got every country being listed, and we got data for each of the weeks. So it'll be nice to see how many cases each country had. So we just need to do an aggregation. So in order to do that, we need to import the aggregate function sum. So let's do that. And I'm going to create another data frame. So I'm going to call this one as total df equals df dot, we want to do a group by on the country name. So I'm going to call that one country, and then we want to do a aggregation. So I'm going to do aggregation, and that's going to be a sum on the weekly count. So let's do that. So that would be weekly count, right? Weekly count. And also I want to rename this field once it's been counted, summarized, to total count. So let's do that. Total count. So this data frame now has the total number of COVID cases per country. So let's take that and we'll display. So all of that is there. So it'll be nice to see which countries have had the cases higher than 1 million, say. Let's do a filter. So that's only 11 countries. So Databricks Notebooks gives you another nice feature. So you can create charts on those ones. So I'm going to try and do a bar chart. So let's go here and create a bar chart. As you can see here, we've had Russia with around 4.5 million cases, and UK with about 4.29, and France is very close as well on 4.28. So I hope this has given you an understanding about how to do PySpark within Databricks. So that's nice, but I want to show you one more thing, which is how to create a table and then switch between two different languages within the notebook. So let's create a table from this data frame. So that is a total df, and you got to do write.save as table. I'm going to call my table as COVID cases. Okay, so that's creating the table. Okay, now you can query this table like you would normally from a SQL command. As you know, our default language of choice here is Python, but there is something called magic commands you can use to switch between different languages. So you do a percentage, and then if you do SQL, now you can issue SQL commands from here. Select star from COVID cases would list all the data from that data frame or the table. So now you can combine it. So if I just said select star from COVID cases where total count greater than 1 million, greater than 1 million. So that would give us the 11 countries. And then if I just did order by total count descending, then that would give us the country with the highest number of cases on the top. So that is Russia. And then again, you can use the visualizations here as well. So you could do a pie chart for as an example. So you've got these 3 countries roughly having 14% of the total number of cases. So that's how you switch between 2 different languages. So you can quite easily use SQL in here, Python, Scala, or R. So in order to do Scala, for example, you would do percentage Scala, and then you can do it. Or you create a notebook which has got a default language of Scala, and then you can switch to Python by percentage Python. So that was an introduction to Azure Databricks. Hope you enjoyed watching the video. If you did, please like the video. If you like the content that I'm making, please subscribe to my channel and use the links in the description for more content. I'll see you in another video. Bye for now.